Welcome, everybody. We're looking at Unit 4 this evening, and we are going to go through the concepts that are important for this unit. This lecture video should be somewhat brief, but we're basically moving now into our last of three important problem-solving techniques for programming, which is to use repetition. In other words, repeating code in order to solve a problem. So when you think back to our first unit, when we talked about problem solving, that was unit X, we identified that there was sequential steps. Then we identified that there were decision statements, like if statements, basically. And now we're moving to the repetition statements. There's two major types of loops in Pythons. And basically, the two types are while loops and for loops, which I do have listed right down here. Now, what's kind of interesting about both of these approaches is that with a while loop is a type of loop that will kind of operate sort of like an if statement in a sense, because we do have a statement inside of it. And you'll notice here that right after we use the keyword while, we're checking the value of a variable against another value, kind of like we do in an if statement. So this will evaluate to true or false. So notice that count is preset to 0, right? So count is less than 5. And while it's less than 5, we'll go to the indented code that's within the looping block, and we'll output, that count, which, initially will start at 0. Every time we loop through, we'll increment by 1. And then it'll just repeat. And basically, if you can think about how this would start out, this would start as 0. So it would print 0, it would add 1 to count. Then it would print 1, add 1, and it would get up to 5, right? So it would print 4, then it would increment to 5, and it would come out here, and then the statement would be false, and it would jump out, right? Now, one of these things that's really important here is the fact that this variable that we're using to control the loop, we'll call that a loop control variable. The other type of thing that we'll call that sometimes is a sentinel value, like we're looking for that value to allow us to proceed, basically. And think about this, if I did not increment this piece of code here, so if I didn't increment this variable, this loop would print 0 and then just keep printing 0 forever, because it would never increment up to 5, right? So that's why we say here, watch for infinite loops. While loops are pretty useful in a number of different ways. And, one of the more useful, ways that we can use a while loop, in my opinion, is to do things like keep a program running. So we can put our whole program body inside of a while loop. We can display a menu for the user, like, do you want to, let's say, calculate a value or exit? And the program would keep running until they choose the exit option. So that's one way you can use a while loop. It's also used a lot for user logins and other things like that. The other major type of loop is a for loop. And a for loop is one in which we control the number of iterations in the loop. So we control how many times it runs by virtue of the things that we arrange here. So what's kind of fascinating about this, right? In this case, we're setting up a loop control variable, but notice we're not predefining it. It actually would start out, within the loop structure here. So where would it start? In this case, when we say range 5, it'll count up to 5, but starting at 0. Well, interestingly, with the range command too, and I'm going to go to W3 Schools to show this in a second, you never quite reach the top end of the range. So I think that's a pretty fascinating little thing. Range can have 3 different parameters within it. So one would be, if it's just a single value, that's where we stop, right? And once again, keep in mind, we'll never count up to 5, right? It'll be excluded. But we can have a start point and an end point. So that, for example, this could say 1, 5, meaning we'll start at 1, we'll count up to 5, we'll never reach 5, we'll reach 4. And then you can also include a third parameter, which is the step, which is, let's say if you don't want to count incrementally by one, you can count by two, or you can count by five, whatever that value is, or even a negative number to go backwards through a sequence of numbers. What I think is fascinating about for loops in particular is that for loops are the ones that programmers often go to by default, first. What I would encourage you to do is come into W3 Schools here and try out some of these loops so you can see how they work. So you can see with this one, for example, while I is less than 6, it'll print the sequence of numbers. And notice, because of our logic here, it'll never reach 6. If I throw in an equal sign and run it, of course, it will reach 6, because now we're including 6. But then once it increments to 7, it jumps out of the loop. When we look at doing loops, one thing that we can do is we can run interesting code like this. And this can be very useful, for example, to jump out of a loop, aside from reaching, the value that rings this to false, basically. So in this case, they can look to see, like, if I gets to the point where it's equal to 3, we can break out of the loop. So break is a command that we can use to jump out of a loop structure. And usually we'll use it in this capacity. We'll have like an if statement where we're checking for a certain value of some sort. If the user chooses to exit the program, and whatever that value might be, like 5 or an X or something like that, then we can break out and we move past the loop. So that would be one little extra command. We also can throw in a continue command. So even if it hits this point, you can go ahead and execute a piece of code, maybe to put something on the screen, but then you say continue and it keeps on with the loop. So that's another thing you can throw in. While loops, because they sort of are like if statements, right? Because they have this true false, they also have an else. And so the loop would execute until it reaches 6. And then when it gets past that point, it would print this and then move out of the loop. I see this used very rarely with while loops, frankly, but I just like to point out that it's there. Some people do use it for some reasons. All right. If you start to look at the for loop, and we're looking here at the W3 examples, here's an example where this loop has a range set up. And I want you to notice that we have a starting point and an ending point. And I want you to notice that it'll loop through and print each variable until it reaches 8. Notice it never reaches 9. So one of the little hacks you have to do here is to make sure you set that second parameter to one higher than what you need it to be, right? And that's kind of a bizarre thing to do, but watch, if I set that to 10, this loop will only output to 9. Okay, so that's a really important thing when using the range command. For loops are also really useful in traversing data structures. Here, we haven't learned about lists yet, but that's coming up really soon in our course. But we have learned about strings, which are collections of characters. Well, this would be a collection of strings, right, that you see here inside of square brackets. One thing that loops do really well in Python is you can traverse the structure of the whatever data structure you have. So if I run this loop, it'll go through and print out everything in that list. Well, I guess it was already printed, but it automatically will cycle through that data structure. X becomes our loop control variable, and anything that appears in fruit as data. So example, apple would go first, would drop into X, and then we could print it. And then we go to banana, and then we go to cherry. So loops can also traverse data structures automatically. If you know other languages as a background, some people think of this as a for each loop. Python doesn't distinguish between the two. It's just a matter of the syntax you lose in the for statement. They do have a little tutorial here that if you want to follow that, I would recommend that you check that out. Break and continue also work in for loops. And once again, you would do this based upon whatever the logic of your program is. So that's the basic structure of loops. Now let me get us back to our core shell here so we can look at the next topic. One of the things that we do look at, right, and I have a couple of loop examples here. It's a very common loop algorithms, including going through a for loop and traversing a data structure of some sort, or finding something that is part of a data structure already, looking for min and max numbers, and then, of course, searching for an item. So, for example, if I iterate through this structure, items would be a data structure holding values, usually multiple ones. And if we find something in that list that equals our target value, then we could flip found to true, and then we can find a way to exit the loop. And normally what we would do here is we'd put in a break statement and jump out, and that's not represented here. Another thing that kind of gets a little bit heady with working with loops is this concept that we can take one loop and place it inside of another. This is often used, as it indicates here, for making grids or tables or patterns in code. So, like, if you think about it, if I wanted to make like a multiplication table, a very common programming problem, I might run one row of numbers, and then I want to print another row of numbers. And what you'll recognize is that it's a repeating process. So I can put one loop inside the other. And the way that this would operate is the outer loop would kick in, and you see right away we go into the inner loop. So the inner loop would run through its whole range of operations. And then when it's done, we go back to the outer loop and run it again and do that again. So this would basically run twice internally and then 3 times externally. And then if you multiply that out, that's 6 total times of iteration. And I think it's kind of interesting, but it can also get confusing. And yes, you can nest more loops inside a loop, so you can go many layers deep if you can conceptualize it. So that's totally allowable. Usually, I see most people stick to about 2 or 3 levels inside of a loop inside of a loop. There's also this process that we call hand tracing, which is to take code and step through it manually, line by line, to predict what it does. So often when you're doing loop stuff, it gets a little difficult to like conceptualize it. So it's not a bad idea to like write down what the value of a variable is and then manually step through it and go, oh, okay, this time it'll be 5, and then next time it'll be 7. And you can even make a little chart of it if that helps you. But you'll notice that when I teach the coding process in this in class, that I will do that. I'll talk the way through it, and that helps for figuring out how a loop actually operates. I'm going to return to this concept once again as strings as the data structure, because we do start to do homework in this unit that utilizes that. We've been kind of doing it for the last few units already, but basically that a string is really a collection of, this one in particular has 5 data points, and each data point is an individual letter. And then I can refer to each position in it with an index number. So this would be position 0, 1, 2, 3, 4. Notice it's 5 characters long. And then also, we would consider that a length of 5, but the last position is position 4 because we start with 0. It's very easy to process through strings, kind of using the data structure approach that I've talked about above. It's very easy to iterate through, and Python, once again, is very elegant at doing that. We can do things like count letters, check vowels, reverse strings, and do all sorts of weird stuff with it. Another thing we start running into in this unit is the need for generating random numeric values. Python does have a randomizer library that we just call through an import statement. We just say import random. And then depending on the kind of values you want to generate, typically we'll generate integers for the most part. We can run a command such as this. So once we do the import, we can call upon that library. And then, for example, we can pull a random integer between 1 and 10. This is really useful for simulating, as it says here, creating games, simulating dice rolls, or perhaps the randomness of nature somehow. So this is helpful for, I think I have an extra credit exercise on this, so that'll be helpful in doing that. And I'm going to jump down here to where we say computer simulations. And here's an example where we're running the random number generator, and we're having it simulate a dice roll, right? So it can roll the die and come up with a number between 1 and 6. And then we put that inside of a loop, and it rolls, in this case, 5 times. Um, Another thing that I do like to talk about here, and we've been talking about this all along, is this concept of problem solving by taking larger tasks and breaking them down into little pieces. And we're starting to get to the point where some of the programs we're going to write will get a little bit more complicated than the things that we've been working on so far. So instead of like, hey, do this one singular task and then do a calculation and put it on the screen, it might require 20 tasks or 15 tasks or something like that. And you have to start thinking about, how do I break this problem down and put it into little pieces? We still will see the overarching approach of getting input from your user or from a data source, like a list of numbers or whatever. And then we process it that somehow, right? We might do some math. We might iterate through a data structure with a loop. We might, you know, rearrange things. We might, do whatever tasks are necessary to complete the goal. And then typically we'll put the stuff up on the screen. When you start to break your programs down into these areas, it becomes a lot clearer as to what you're doing. This works really super well with console programming, which is what we've been doing so far, which is writing code for the command line. When you get to GUI programming, this structure breaks down somewhat because visual interfaces tend to stay on the screen, so they don't necessarily go away. But we can simulate, keeping a program running once again by using a while loop, and basically putting the whole program inside of a while loop is one technique we will learn. All right, folks, that's the predominance here of the lecture materials for this unit. We also have this PowerPoint from our old textbook. I would encourage you to look through that if you wish. And then, of course, you can go to W3 Schools and read up on this stuff. But this video ends here.